Okay, so what we're going to be doing today is talking about spinning curves around a fixed axis. We're going to talk about the x-axis today. We'll talk about the y-axis tomorrow. So by definition, you can take any f of x curve and rotate it in three-dimensional space around the, we'll start with a fixed x-axis. And that will create for you something that has circular cross sections where all the different sizes go together. All right, so the area is always going to be pi r squared. All right, so if the area is always pi r squared because you're creating something that's circular, the volume will always be the integral of the area. In other words, the integral of pi r squared. Now, the tricky part is how do you get r? Okay, well, r is the distance from the curve to the axis that you're rotating it around. Okay, so r is f of x minus the axis you're rotating it around. In this case, the axis of rotation happens to be the x-axis, so that would be a value of 0. But you could rotate it around any axis in 3D space, and you would be subtracting those two. We'll even do it, we'll do it this way. You could do diagonal. We are not going to do diagonal. We're going to stick to horizontal axes and vertical axes, but you can do oblique axes as well. No, but multivariate calculus does. Engineering students do, of course. Okay. Okay. Multivariate or multivariable calculus. That's where you have x's and y's and z's, like all going into different.
Hooray!
Mm-hmm. That's Calc 3. That's Calc 3. All right. What shape or what curve do you think this could be that's forming the outer edge here? What does that look like to you? It's some kind of probably some kind of a trig wave that's forming the outside. So the outside is going to be formed by some function. The function could be parabolic. The function could be trig. It could be logarithmic. It could be exponential. The outside will be formed by a function. The inside is circular. And the volume is the integration of those circles.
So would this be called a spheroid?
This one doesn't, I don't know.
Because it has circular...
It does.
But it doesn't come to a point.
Yeah, but then it's not prolonged. So then it's just a normal...
I don't know what the actual name of it is. All right, so here we go.
Sorry, I don't know the definition of it.
Okay, if any closed area bounded by f of x, which is the curve on the outside. So you can draw a little arrow and call that the outside curve. The outside curved edge is rotated around the x-axis. The volume generated is pi f of x, and f of x is the radius. So f of x is creating the radius squared. Now, technically, there's a -0 in there because we're using the x-axis. Okay? All right. So we're going to work this one out. The outer edge of this one is being formed by the function that is the square root of sine of x. It's not actual sine of x, it's the square root of sine of x. So you're going to start with the radius of this is f of x minus 0. So in this case, the radius is the square root of the sine of x. So then the area of the slices of circles, if we got our knife out and we started slicing this, the area would be pi times r squared, or pi times the square root quantity of sine of x, quantity squared, which simplifies to just pi sine x. And then the volume is set up as the integral of all of the slices. So each slice is pi sine x. If I want all the slices, I will have pi sine x parentheses dx going along the bounds of the x-axis, which are 0 to pi. And then finding the volume is just a matter of then doing the antiderivative and then simplifying, yeah.
When you do trig functions like sine of x, is it mandatory to have parentheses around the x?
Not if it's just x.
If it's like 2x or x squared eating out.
All right, so I would pull my pi out to the front because it's a constant. And then the antiderivative of sine is negative cosine plus c going from 0 to pi. And then as we evaluate this, we would have the negative cosine of pi plus c minus the negative cosine of 0 plus c. So the cosine of pi is negative 1. So this will be negative, negative 1. The c's are gone. And then it would be plus, because double negative, 1. So altogether, I have a volume of 2 pi units cubed for volume. We don't know if this is centimeters or inches or feet or meters, but it is cubic inches because we're measuring it in volume.
Cubic inches.
Cubic units. Yeah, what did I say?
Inches.
Sorry.
Cubic
units.
We don't have units.
All right, here we go. A region bounded by e to the x and the x-axis. All right, you're not going to get your calculator, so you have to know what e to the x looks like. So the x-axis here, e to the x, you should have a general working knowledge of what e to the x looks like. You should know a little bit about what negative x does between 1 and 2. It doesn't touch the x-axis, but we will be taking the section between here and here, between the x-axis, and rotating it around the x-axis. So the easiest way to draw that is to reflect below the x-axis. All right, do your best to do a reflection. So that is the reflection of that object over the x-axis. When we rotate it, now the edges of it are circular, so you kind of draw some circles here. I usually go like this to help me imagine. So this to me looks like a funnel. Okay, it's open on the, it's not coming to a closed point, but that's what it would look like to me. All right, so I set my radius up first because this is round. So my radius is going to be f of x minus the axis. So for this one, it'll simply be e to the x minus 0. So then the area is pi times r squared, or pi times e to the x quantity squared, which is e to the 2x. Bless you. Then the volume would be on the bounds from negative 1 to 2 of pi times e to the 2x dx. So then I'd pull pi out as a constant and work on my antiderivative. Antiderivative e to the 2x is still e to the 2x divided by the chain rule of 2 plus c, and then we evaluate and we plug in the bounds from negative 1 to 2. I'm not going to go any farther because I don't want to spend our time doing that. I want to do as many examples as we can. Any questions on that one? Set up your radius first, and then it's always going to be pi r squared because these are going to be circular things, and then set up your volume.
How is this different from the ones you've already done?
The ones we have done have had a base formed, and then it wasn't rotated around, it was just growing up out of that base. Okay, and we could grow any shapes out of this. When you rotate, the only shape you can get is a circle. You can't rotate something and get a square. It's not possible. Okay?
But we did some spheres. We did some like circular ones.
You could create a sphere either by growing things out of a circle, or you can create a sphere by rotating.
Okay, so it's essentially like the same as this.
Only in that case.
Only in that case.
Yeah. All right, here we go. This one, you would be allowed to have your calculator because the Math 9 would help you with the antiderivative. All right, so go ahead and grab your calculator and take a look at what the equation 2 plus x cos x looks like. Okay, 2 plus x cos x.
Can you picture it about the calculator?
Only because I've done this one a lot of times.
Oh.
But in general, no.
Ew, what is that?
Ew. We don't look at things and say ew. Okay, make sure you're in radian mode and make sure your window is set to the window that is indicated. Oh. All right, so if you are assuming that this goes through the y-axis at 2, yeah, okay, set your timer. Okay, we've got a graph that does this. Okay, I can do this better. All right, there we go. That's what I see. All right, if we rotate this from -2 to 2 around our x-axis, and you do a reflection beneath, so it's going to look like this. What does that look like to you if you start to make rounded things here? Yeah, maybe some kind of a vase here. That's what I would picture too. A vase turned on my side. We should figure out what the equation that would make a Stanley would be or something like that. Okay, how would we create that? Okay, so our radius, f of x minus the axis. So in this case, it would be 2 plus x cos x minus 0. So then we've got our area, and then we have our volume. Area will be pi parentheses 2 plus x cos x quantity squared. And then volume, I'll go ahead and pull the pi out to the front, going from -2 to 2 of that area. And we'd rely on Math 9 to do the rest of that for us.
So do you.
Okay, then we move into something called the washer method. Washers and discs. A disc, if you slice it, is a solid slice of banana, okay? The washer method, if you slice it, you're getting things with holes in the middle. A washer is something that has a disc removed out of the outer disc. A donut, a bagel, any of those things are called washers. They happen because the original region doesn't touch the x-axis the whole time. Anything that doesn't touch the x-axis the whole time is going to create something that has a gap in the middle. Okay, so here, that region that sort of looks like a flower petal kind of to me, when you rotate it, the outside looks like a bowl, but the inside has a funnel in it. Can you see the funnel on the inside here? Okay, yeah, you can find the volume. So this is all a gap in the middle, this big gap here. Okay, there's a funnel on the inside, but the outside looks solid. So you wouldn't see it unless you actually looked on the inside. From the outside, it appears to be solid. From the inside, there's parts of it are carved out. Okay, and what if you don't touch the x-axis at all? What if your region is like that? Okay, then you've got something where both ends are open and you can see all the way through the middle. Okay, a tunnel funnel. Okay, all right. So you can see that when that happens, you have two subtractions in your interval. All right, you're going to have the outer radius making its own pi r squared and the inner radius making its own pi r squared. Okay, they are two separate entities. So f of x would be what we would call the outer radius. Don't forget to square it. And then g of x would be what we would call the inner radius formed by a different curve. In other words, the lower one. Okay, the outer minus the inner, or the upper minus the lower, if you want to think of it that way. And then you subtract them. You could factor the pi out of both of them if you want, since they both have pi in common. All right, so here we go. Here's that same picture. You just need to know what the upper radius is and what the lower radius will be. So if we are looking at the upper radius, it would be f of x and minus 0, because we're going around the x-axis. So for my picture right here, which of the equations is forming the one that in the region is the higher one? The square root of x. This one is the upper one. Its values are higher. If you're going top to bottom, you still check it the same way. You're going to hit that one as your upper. So it will be, my upper radius is going to be rad x. My lower radius will be g of x minus 0 because of the x-axis. And that would be the lower one, which is x squared. We don't normally think of x squared being lower than a square root, but in 0 to 1 it is. Once they cross places at 1, 1, then it's the reverse, but because we're in 0 to 1. All right, so our area we set up this way. Our area will be pi rad x quantities squared minus pi x squared quantities squared. That's two separate areas because we have two separate edges. Then my volume would be going from 0 to 1, and parentheses, we will have pi square root x squared quantity squared minus pi x squared quantity squared. So that is setting it up correctly. Now before you would do any more math, I would say there are two good things to do. One is to pull the pi out, and the other is to do any simplifying that you might be able to do. So I'd say pull the pi out to the front, and then if I simplify, the quantity of rad x squared is x. And then the quantity of x squared squared is x to the 4th. And then you're looking at that and you're thinking, yep, I can do that. I can do the antiderivative without too much pain. I'll get half x squared minus a 5th x to the 5th plus c, and I'm just going from 0 to 1, so that's just plugging in a bunch of 1s and 0s, and I can go for the rest of that. Okay? Mm-hmm. Yeah.
Can you like pull the pi out in front in like the area section and just put it in front for the volume?
Sure.
Okay.
Sometimes people who do that forget then to put pi back in their answer. It's like it disappears. So as long as pi doesn't disappear. Okay, all right, let's try again. Okay, a region that's 2 plus cos x, and I would expect, okay, here's one you should do without your calculator. 2 plus cos x. Everybody knows what cos x looks like. So you should also know what 2 plus cos x does, because it just bumps it in what direction? Up 2. So if we know that regular cos x looks like this, then if you bump it up 2, then cos x is going to be up here. Okay? So there's our cos x, and then the other line that is 1. So that would be like this. There's 1.
Oh, okay, yeah.
Okay? Because this is the x-axis.
That's a weird shape.
Okay, so you have this shape in here from where they intersect, and we are reflecting this and rotating it around the x-axis. So what it would look like is I would get, if I was trying to draw it, I would get this shape that was reflected below it, and then rotating it around, I'm going to have a cylinder cut out of the center, like that. But the outside, you can't see the cylinder. Kind of looks like a bead, sort of, to me. All right, there we go.
It's definitely
A wormhole.
yeah.
All right, so the outside looks solid, but the inside you can see right through the middle. So this is a washer. All right, so we're going to do the outer radius. So the outer radius would be f of x minus 0. So in this situation, it simplifies. You might be thinking, why is she bothering to always write minus 0? It's because tomorrow it's not going to be the x-axis anymore. So I want you to get in the habit of thinking about that there's a minus something right there.
It's like a future from
Okay. All right, and then inner radius would be g of x minus 0. In this case would just be 1. So my area will be pi times quantity 2 plus cos x squared, that's pi r squared, minus another pi r squared, or pi 1 squared. I don't know. And then finally the volume. The volume would go from -2 to 2. And we'll have 2 plus cos x quantity squared minus pi times 1. The whole thing has parentheses around it, and then dx. You could make your life easier by noticing that this shape happens to be symmetric. The left half and the right half are completely the same. So you could make your life easier by making the lower bound be a 0, and then putting a 2 out in front to double the whole thing. Okay, that would help you just in evaluating. You'd have to FOIL and pull out a pi to simplify this. Okay.